Good morning. This is Ms. Billerbeck, and we are going to talk about 8.3 quadratic functions in standard form. So standard form is written f of x equals ax squared plus bx plus c. So it's in descending order from highest degree to the lowest degree. So this is where a cannot equal 0, because if a was 0, we wouldn't have a quadratic equation. We'd have a linear equation that equals bx plus c. So a cannot equal 0. C is the y-intercept. Okay, we also have a special equation that should be in everyone's notes and embedded in their memory. X equals negative b over 2a is the line of symmetry for the parabola of this quadratic function. Also, the negative b over 2a is the x value of the vertex. So those are some important things to note. All right, so let's take a look at, let's evaluate f of x equals ax squared plus bx plus c for x equals 0. So we write this as f of 0 to keep track of what value of x we're going to be using. So then we write a times 0 squared plus b times 0 plus c, and we see we have f of 0 equals 0 plus 0 plus c, so it just equals c. Well, in the scheme of things, that gives us a coordinate of the y-intercept. So if we have y here and we have x here, and we have the value of x at 0, then f of x is right here at c. So we have the coordinate 0c is your y-intercept. Okay, so if we had a parabola that was drawn on this, it would look like this. All right, so it doesn't matter what A and B are, C will be the y-intercept. All right, let's look at another example. So this one we want to graph f of x equals x squared plus 2x plus 4. So we know we have 1 point, the 4. So we have a y-intercept right here. So that's 1 point. Now we want to find the axis of symmetry. So we have x equals negative, let's put the negative in line with a fraction bar, b over 2a. So if we look at this, we have a equals 1, b equals 2, and c equals 4 from the equation itself. So substituting that in, we have negative 2 over 2 times 1. So 2 divided by 2 is just negative 1. So at negative 1, we have our axis of symmetry. So we can draw the axis of symmetry with a dotted or dashed line. Okay, we also know if we have a point here, 1 away from negative 1, then we have a point over here on this side of it. That's the joy of the axis of symmetry, is it does half of our work for graphing. We also know the vertex is going to be at negative 1, so we can plant plug in f of -1 into the equation to find this vertex. So we have -1 squared plus 2 times -1 plus 4. So that gives us 1. And then we have -2 plus 4. So that gives us a -1. So this equals 3. So we're at -1, 3 right here. So our vertex is at -1, 3. And we have the y-intercept. And that's at 0, 4. And we have our axis of symmetry here. And that's x equals -1. So all we have to do now is figure out, well, let's plug in 1 because that looks like it's the next point on that. So let's see what f of 1 is going to be. And from that, we can just find the other point over here because of the axis of symmetry. So if we have 1 squared plus 2 times 1 plus 4, that's going to give us 1 plus 2 plus 4, which is 7. So at 1, we're up to 7. So we have a point right there. And since that's 1, 2 away, we can count 1, 2 and have our other point there. So then we can graph our parabola. Usually you just need 3 to 5 points for a parabola. 5 is always best if you can do 5, but sometimes it gets very large fast, so you can't quite do the 5. So that would be our graph of our parabola. Excuse me. It's allergy season in Sacramento. All right, so on this equation, or this graph, we have g of x equals -3/4 x squared, and we have plus 3x minus 4. So we see we have a equals -3/4, b equals 3, and c equals -4. So we have y-intercept at -4 down here on the y-axis. And we need to figure out, well, what is going on? We know it's going to open downward. So we probably can use some space over here. So let's do G. And, oh, we don't want to plug anything in yet. We need to figure out what is the axis of symmetry. So we have x equals -b over 2a equals then we have -3 over 2 times -3/4. So there's 2 negatives, so we're going to have a positive value. So our axis of symmetry will be over here. So this is the same thing as 3/2 divided by 3/4. So we're going to change flip. So we have 3/2 times 4/3. That cancels. We can take that out. So this is going to equal 2. All right, so that was an important thing to have. So now we have 2. We know it's opening downward. And we know the vertex is going through 2. So we also have a point, since this is 2 away, we have a point right here. So now let's plug in another point. Let's use this area since we know it's going down. We don't know exactly how high up it is. So we have f of, or this is g of x. So we want to use g. G of 2, and we're going to plug that in negative 3/4 times 2 squared plus 3 times 2 minus 4. So 2 squared is 4, so that's going to cancel that out. So we have negative 3 plus 6 minus 4. So that's negative 7 plus 6. So that gives us negative 1. So we see that our vertex will be right here. So the vertex is going to be at 2, negative 1. And our axis of symmetry is right here. And then we need one more point probably. So it looks like we probably want to keep it even because we have an even right here. So let's try 6. And it might not fit on here. So this could be one of those 3-point graphs I was talking about. So let's see. So let's do g of 6 equals negative 3/4. And we have 6 squared plus 3 times 6 minus 4. Okay, so 36, 6 squared is 36 divided by 4 is 9. So we have negative 3 times 9, which is negative 27 plus 18 minus 4. Okay, so that gives me negative 31 plus the 18. So that gives you, so 31 minus 18 gives you 13. And that's going to be negative. So yeah, we're off. So that's what I was concerned about. So this is one of those ones where we are going to do just 3 points. Okay. And we want to mark our y-intercept. So the y-intercept is going to be 0, negative 4. And there you have it. So if we compare our two graphs, we see that, well, we had a negative 3/4 here, which made it open a little wider. And it also opens downward, and we had our y-intercept at negative 4. This one we had a positive a, so it opened upward, and it was more like the parent function, but it's just shifted a bit. Okay, so let's go ahead and compare negative 0.3 x squared minus 0.6 x minus 0.2 to this graph. Okay, so we know it's opening downward. We see we have a y-intercept at 0.2. That's not very big. 0.2 is 2/10, which is 1/5. So it's right here. So we need to find where is this axis of symmetry. So we have A equals negative 0.3 B equals negative 0.6 and C equals negative 0.2. So our axis of symmetry will be negative B, which is a negative 0.6, over 2 times negative A. Whoops, that's a 3. Okay, so this ends up, we have a negative 0.6 over negative 0.6. So this cancels as 1, so this just equals negative 1. Okay, so let's draw that axis of symmetry at negative 1. That's a lot of negatives. This axis of symmetry, by the way, is right here. All right, so I have 1 point over here, so that means I have 1 point over here. So don't miss the easy points, okay? Those are nice to have. So we had to figure out things that are easy to use. So it might be using 1 might work really well. So let's try what happens when it's f of x, f of 1. So we have negative 0.3, and we have 1 squared minus 0.6 times 1 minus 0.2. So this ends up negative 0.3 minus 0.6 minus 0.2. Okay, when we add that all together, we get negative 1.1. All right, so at 1, we're at negative 1.1, which is right here. So it just nicks that one. That's 2 away. So we count 2 away here and go to negative 1.1. Okay, so it's super close to 1. There we have it. And we had the white, we forgot to find the vertex. That is very important, by the way. So we have the vertex at negative 1. So let's put in f of negative 1. So that gives us negative 0.3 times negative 1 squared minus 0.6 times negative 1 minus 0.2. So that gives us negative 0.3 plus 0.6 and then minus 0.2. So we have negative 0.5 plus 0.6, which gives us a 0.1. So we find that we have our vertex is going to just be above this axis. It won't be right at 0. All right, these are looking somewhat similar, like they could just be shifted. So let's keep going. So I guess the next one would be if we did 2. So let's try that. I'm going to move over to here. So f of 2. Now the nice thing of putting your x values in here too is you know exactly what you have tried. So we have negative 0.3 times 2 squared minus 0.6 times 2 minus 0.2. So this gives us negative 0.3 times 4, which is negative 1.2 minus, and that's again 1.2 minus 0.2. So that gives us negative 2.6. So at 2, we're at negative 2.6. Now this isn't increasing very quickly, and we're 1, 2, 3 over here. So 1, 2, 3. Isn't it lovely using the line of symmetry? So when we do this, this looks remarkably like a shifted parabola of the other one. So see how this looks just like the other one. So someone was trying to fake us out. I think this is the same parabola, just shifted. And it has a different, it does, it's the same parabola. Okay, so it's the same parabola, it just has a different line of symmetry, and its vertex is slightly raised here. All right, so there we have it. All right, let's look at Simon. Example 5, Simon threw a ball to Hannah. The ball flew per f of x equals negative 0.25 times the quantity x minus 1 squared plus 6.25 in feet. So we notice this is not standard form. This is vertex form. So we know what the vertex is because it's vertex form. So how high was the ball when Simon threw it? Well, that one, we just put, that happens when x is 0, because Simon is at the 0 starting point when he throws the ball. So we're going to do f of 0 equals negative 0.25 times 0 minus 1 squared plus 6.25. So this becomes negative 0.25 times, and this is just negative 1 squared, which is 1, plus 6.25. So 1 times 0.25 is just negative 0.25. So when we add that together, it's at 6 feet. So when Simon throws the ball, he's not throwing it over his head, he's throwing it about head level since he's over 6 feet or about 6 feet. So how high does the ball go? Well, he's not throwing it very hard. So the maximum height of the ball is where the vertex is. And we know the vertex because it's vertex form. So H equals 1 and K equals 6.25. So the vertex is at 1, 6.25. So the maximum height is 6.25 feet. So he's just doing a little tossing the ball with Hannah. So it's not going very high. They're not very far apart. Okay, so that's the maximum height. Let's look at these parabolas really closely again and talk about maximums. So when we have a maximum, it's like the top of the mountain. So this one would be the top here. So both of these vertexes are maximums. But when we have a parabola that opens upward, we don't have a maximum, we have a minimum. So that's an important note when you're dealing with parabolas, because we do have to note minimums. So the vertex is at a minimum here. All right, that's it for standard form. I hope you have a wonderful day. Bye-bye.